Hello there. Welcome to Twitter Think. My name is Daniel. I'll be taking you through the second phase of implicit function. I've labeled this one part 2. There's something simple and different about the first video I did under this topic, so I intentionally decided to pick this example to go through this one with you too, so that whenever you come across something like this, you will not say you have never seen it before. So let's box on to what we have today. If you haven't subscribed to this channel yet, kindly click on the subscription button and subscribe for more updates. So there are some basic rules that I explained in my first video. I think I'll just go over it briefly, so that in case this is your first time watching this video, you can locate Engineering Maths 1, my playlist, the Engineering Maths 1 playlist, locate implicit functions, differentiating an implicit function part 1 to go watch that video for more examples. So this is the rules. When you have an implicit function, all you need to do is to apply derivative to both sides of the function, to the left and the right. So apply derivative to both sides. Then in your next step, use the derivative to multiply each term one by one, especially on the left hand side. That is what you do. Then you differentiate each term one by one accordingly. Then you factorize dy dx by grouping all functions containing dy dx to the left hand side of the equation. So by the end of the day, all functions containing dy dx, functions that you differentiated y with respect to x, you group them to the left hand side and you equate the function to 0. So that is it. Let's start this example. The rule says that apply derivative to both sides of the function. So remember, we are differentiating the whole function with respect to x. So derivative of 3x squared plus y squared plus 3xy, there's supposed to be minus 3. I didn't bring that, equal to derivative of 0 dx. So sorry for this mistake. Then I will use the derivative to multiply each term one by one, like I said in the rule. So derivative of this, it will give me d of 3x squared dx plus d of y squared dx plus d of 3xy dx minus d of 3 dx, giving me d of 0 dx. So now the next step is to differentiate each term one by one. But before I will do that, there is a product function here. These two functions are multiplying themselves. It's actually 3xy. So 3 is affecting both x and y. Some of us have been having a lot of issues here. These 3 affect all the functions. It's the same as 3x, 3y. So put that in mind. So I'll use product rule to break down this function before I will apply the derivative to all sides. So let's repeat the other sides and then we apply the product rule here. So d of 3x squared dx plus d of y squared dx. Then there is a variable multiplying this. For simplicity's sake, factorize that variable out before you apply the product rule. That is the easiest or the simplest method. You can also decide to work with the 3, but remember that if you hold x, you are holding 3x, and then if you hold y, you are holding 3y, not only y's. Most students that I have seen or that I have taught actually were making a lot of mistakes and having something like this. So the easiest way is factorize the variable out plus 3. Let me bring a bracket. Then I can now apply the product rule. Hold the variable x, differentiate the y, or use d ds to multiply the y. It means you have differentiated. So dy dx plus, now hold the y, maintain y, differentiate the x, or use d dx to multiply the x, dx dx. So that is it. We are done applying product rule. Then we are left with minus d of 3 dx equal to d of 0 dx. So this is very simple. Go through it very carefully. Now I can now differentiate each term one by one. So when I differentiate this side, these two will multiply the 6, you reduce the power by 1. So I am getting 2 times 3 will give me what? 6. X 2 minus 1 will give me 6x raised to the power 1 dx. Now the only difference in implicit function, which I explained in my first video, is that you differentiated the function x with respect to ds. So you show it, I differentiated x with respect to s, so ds dx, plus we are differentiating y squared. So you use the same process, 2 times the function 2 minus 1 to give us 2y. 2 minus 1 will give us y1, which is the same as y dy dx. Now this means that you differentiated y with respect to what? X. So you indicate, if you don't indicate these things, everything you are doing is wrong, so pay attention. Plus, now there is nothing to be differentiated here, it's already differentiated because there is no power here. The power here is 1, the power here is 1, so ds is the same as what? 1. And then dy ds is the same as dy ds. You don't need to differentiate it by saying 1 times this one. No, that is incorrect. So this will give you, now you can use the 3 to multiply each term, but let me do that. 3x dy ds, that is what we have here, plus now this 3 will multiply the next function, 3y dx. There's no need to repeat this step, but I'm doing it for the sake of those of us that have problems. I will take them out. ds is still 1. Then minus, when I differentiate a constant, the result is 0. So minus 0 equal to, when you differentiate 0, the result is also what? 0. So we get it now. Why do we say that the differential of 0 is 0? Assuming that I have 3, then it's the same as 3x raised to the power 0 or 3y raised to the power 0. When I differentiate this, it will give me 0 times 3, the power times the function, 0 minus 1, everything is 0. So that is why we say that the differential of a constant is always 0, so that side is what? 0. Now we group like terms for all functions containing dy dx. This has dy dx, this has dy dx. So we can group like terms for them. We will group them to the left hand side, then we bring the other functions that are not having dy dx behind them, and we equate the function to 0. So I will start with this one, 2y dy dx plus 3x dy dx. You can choose to start with x or y, any of them is still correct. Then plus the remaining function, this is ds, it will cancel, giving me 6x. Then we are left with this one, plus 3y, this is ds, it will cancel, giving me 1. 1 times the function is the function, minus 0 is still the same, equal to what? 0. I can now factorize the dy dx out. Let me start with this one. I want to start with the x. So I have, when I factorize dy dx, I have 3x plus, when I factorize this, I have 2y. Put everything into bracket, dy dx plus 6x plus 3y equal to 0. So now, remember, you can just maintain your 2y here and 3x here. You still get the same thing. It's still correct. Now, don't bring the factorization dy dx here. Let's assume everything here is the coefficient. That's how I want to explain it. So, put the dy dx behind the bracket. Okay, if I have a function, it's 2 or 3, whatever function, dy ds, not dy ds the function. It is not mathematically correct. So, let's put it behind this one. So, this is the solution. You are done. This is implicit function. So if this video has been helpful, kindly subscribe to my channel. My name is Daniel. I will take you through more examples under this topic. See you in my next video.